In the diagram of the parallelogram ABCD below, we know that BE is perpendicular to CED, so we could just mark that down like this. And we also know that DF is perpendicular to BFC, so let's mark that on down. Now it also says CE is congruent to CF, so we're going to mark this and this. Now we want to prove ABCD is a rhombus. Now, first thing to always do when you're writing a proof is just like come up with a strategy, because this is a kind of tough one at first look. Like, ooh, how are we going to do that? And I'll tell you this. The approach we're going to take is this. We're going to try to prove that these two triangles right here are congruent. So we have this triangle. All right. And then we have this triangle right here. All right. First step is going to be to prove the triangles are congruent. That's step one. All right. Prove triangles congruent. Now, once I've done that, I'm going to do a CPCTC proof to prove that BC is congruent to CD. So I'm going to do BC congruent to CD from CPCTC. All right. And then to end it off, I'll know that that's a rhombus because that will show me that the consecutive sides are congruent. And if you have consecutive sides that are congruent, well, then you know it's a parallelogram because, I mean, it's a rhombus because the opposite sides are congruent also because it's stated that it's a parallelogram. You have 4 congruent sides. That's it. So we just got to write the proof now. We've got our strategy. So let me get this all out of the way. So my recommendation is this. Always, whenever you have overlapping triangles, what you should do is redraw them separately because that'll just make the problem pop out to you a little bit. It makes everything a lot clearer. So you have your first triangle here, which would be BCE, very poorly drawn, but that's what it looks like. Then we have this triangle right here. All right, terribly drawn again, and this is FCD. Ugh, gross. Maybe you could do a little better. Now we just want to remark what we see, and we know that CE is congruent to FC, right? We know that we have right angles at CFD, which is right here, and we have another right angle at CEB, which is right here. And then also, here's the thing that's missing. You might remember that if they both share this angle C, then because of the reflexive property, it must be congruent to itself. So C is shared on both of them. Well, look at that. The two triangles are in fact congruent. We have ASA congruence here. So we've done a pretty good job now, and looking at it separately makes it a lot easier. Now we just got to write the proof out. So I'm going to zoom out a little, I'm going to move this on up, ooh, and let's actually write this proof out. See you over here. We got our statements, and we got our reasons. Now the first step is always to rewrite your givens. So we're going to say, why did I even do that? A, B, C, D is a parallelogram. That's one. That's our one given. Our second given is that BE is perpendicular to CED. That's our second given. We know that DF is perpendicular to BFC. Right, that's our third given, and then we know that CE is congruent to CF. All right, well, now that we got that written out, what we're going to do here is we're just going to continue along with our proof. So we've already stated that one thing. We know that CE is congruent to CF. That's been stated. Now we have to explain the other things that we marked. So let's do the easy one. We're going to do the reflexive property. So I know angle C is congruent to angle C. And that's the reflexive property. Okay. Number 6, we're going to do the right angles. Remember, when we have perpendicular lines, we're actually going to do this in 2 steps. First, we're going to state the right angles, and then we're going to state that right angles are congruent. So our first step is to state which 2 angles are right angles. So we know C, angle CEB, and angle DFC are right angles because perpendicular lines make right angles. intersect at right angles would be the technical language. But I think we got the point. Okay, then we're just going to say now that they're congruent. So now that I know that they're right angles, I can now state that the two angles are congruent. And that's because all right angles are congruent. We're going to continue along here. So now that we've said why everything's congruent, we'll state that the triangles are congruent. So we have triangle BEC is congruent to triangle DFC. And we know this because of ASA congruence. Now, if you remember our strategy, once we've proven the triangles are congruent, we can now prove that BC is congruent to CD. And that's our CPCT part of the proof. That's corresponding parts of congruent triangles are congruent. CPCTC. And now part 10, I gotta go over here because I've run out of room. Now we could just state what we're trying to prove, and that's ABCD is a rhombus. And I know that because as we've just stated, consecutive sides are congruent. And that is how we would do this proof. Yeah, that's it. 10 steps, and you got it going on. Let's on to this guy, okay? So this is a fun problem, and I think it's pretty straightforward. It's good for 6 points. Let's just go into it, though. So the question here says, Walter wants to make 100 candles in the shape of a cone for his new candle business. The mold shown below it will be used to make the candle. All right, well, it's good that he told us a cone, so we know what shape we're using. Each mold will have a height of 8 inches, so we're going to mark that down, and a diameter of 3 inches. We'll mark that down. To the nearest cubic inch, what would be the total volume of 100 candles? So all we have to do is start by finding the volume of one cone candle, right? And so we'll take the formula from the back of the Regents book. It's given to us. 1/3 radius times height. We pretty much have all the information here, right? Our radius is 1.5, half the diameter, squared, times the height, which is 8. And our volume is going to be equal to 18.84955592. That's inches cubed. So that's one candle. But this says we want to find the volume of 100 candles. So we're just going to multiply this guy by 100. We're going to say the volume of 100 candles is equal to, and 1884.95592 inches cubed. But that's not how we're going to finalize our answer, because this says to the nearest cubic inch. Always be clear on what you're rounding to. So let's state clearly the volume of 100 candles is 1885 cubic inches. All right, part 1 done. Sweet. Now the next part of this question says, if Walter goes to the hobby store to buy wax for his candle, Walter goes to the hobby store to buy wax for his candles. The wax costs 10 cents per ounce. If the weight of the wax is 0.52 ounces per cubic inch, how much will it cost Walter to buy the wax for 100 candles? So the first part of this is we're going to find out the weight. All right, so weight is measured by, weight is density times your volume. Now the density of this, of wax, is 0.52 ounces per cubic inch. And the volume, well, we just found that, is 1885 for 100 of them. When you multiply those together, you get something like 980.192. All right, now to find the cost, what we're going to do is say the cost is just equal to your unit price, which is 10 cents here. And we're going to multiply that by our weight, right? This is like what they do with 16 handles. It's your weight of your ice cream times the unit cost of the ice cream. And when we do that, we find out that our cost is going to be 98.0. And the number keeps on going, but we have to stop at cents. So it'd be 1792. But we can't have that much. We have to round this to the nearest cent because you don't have like 100th when you're dealing with money. So it's just 98.02. That would be our cost. then finally, the third part of this question is, if Walter spends a total of $37.83 for the molds and charges $195 for each candle, what is Walter's profit after selling 100 candles? So his total costs are going to be $37.83 for the molds plus the $98.02 that he spent on the actual wax. So that comes out to $135.85. All right, that's his total cost. All right. Now his revenue, that's how much money you take in, is going to be the $1.95 he gets from each one of them multiplied by 100. So we get 195.00. All right, and your profit is just when you subtract how much money you made and how much it all cost you. So he made $195. All right, and all his costs totaled $135.85. Subtract those from each other to get the total profit of $59.15. Done and done. All right, that's it for this Regents. You are done with this. Hopefully this was all very helpful. I'm out.